Hello everybody, and welcome back to the Myth of Life channel. Today we're going to continue on our mini-series part 2 of Can We Survive? If you remember last time we spoke heavily about the livestock-based diet, a little bit about the land use, a little bit about the deforestation and the greenhouse gas emissions, but we focused heavily on the water consumption. Actually, it was more like water extinction, as we disclosed at the end of the video how it's quite possible we're going to run out of water in the next 20 years if we don't stop what we're doing, or at least change our habits and lifestyles. So today's part 2. Today we want to focus a bit differently. There's some acronyms we need to share with people, and those acronyms are going to help us understand a lot of terminology that scientists use when they do their research. And in explaining the acronyms, it's also going to help you understand the concept of some of the previous and the future sharings we're going to do. We're going to put everything up on screen for you so you can see what we're talking about in great detail. And I just want to share again very carefully that our information and our fact data science sharing is coming from reputable sources. It's not coming from funded one side or another of the argument of it. It's from a neutral agenda, usually from like FAO, World Food Program, UN, a non-partisan university. We have to be careful that we take data that's not sponsored by one side or the other, because
heroes never die.
It's going to be a little bit of sensationalism. It's going to promote exactly the argument they're trying to provide. Our argument is trying to provide the truth. And so we're going to start. So on your screen now, I've put up a slide with the acronyms in general, and you can see there's 5 of them. We're going to start with the first one. It's called LUR, Land Use Ratio. It's a little harder to explain than what it sounds. I'm going to try. So, land use ratio is the maximum amount of human digestible protein, another acronym, HDP. Human digestible protein from the food crops on all land used to cultivate feed required to produce 1 kilo of animal-sourced food in that 1 kilo. So that means that how much farming do we do, the land use, that goes to the feeding of the livestock to produce the final meat product. So if I put it in simpler words, this means the total land used to produce 1 kilo of animal protein from rearing, grazing if you will, land used for the cultivation of crops and feed. It's kind of like a throughput. Think of it very simply. It takes X amount of land and resources to produce 1 kilo of meat. And that's your land use ratio. It's everything that land is used for to get a kilo of meat. So I'm going to show you a graph now. It's HDP, it's a human digestible protein. Maybe I'm getting a little bit ahead of myself, but you can see on this chart though, there's different levels. On the left side of the axis, you can see it's the kilos of receivable crop or meat from an acre of land, to give you an idea. So you can see like wheat is about a little over 3,000 kilos per acre of usable, and that's measured by bushel and kilo per bushel. Rice again is a little higher than wheat, heavier crop. You get about 3,500 kilos per acre. Then you can see corn is about the same as wheat. Then you can also see pork as an example. On the same land mass of 1 acre, you would get about a little over 1,500, maybe 1,650 kilos. And then you see the beef. It looks like it's not there. It's there. It's really, 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 really low. We're talking like 5 kilos. And we've been very careful when we put this chart together, because we also understand that you can get a couple of wheat crops, a winter summer crop of wheat, you can get a couple of crops of corn, even pig. It's not like it takes a year to harvest a pig. It's about 7 months maybe. So we know it's more than one round of pig in a year. Having said that though, the cow is a minimum 18 months before it's considered finished. So we took all that into consideration when making the chart, and you can see the final yield per kilo in that acre of land. So how we're getting back, like an investment style, we put in, what did we get back from that investment? Now the second chart I'm going to show you is a land use chart. Now that one's pretty impressive. When you see the top one, it's a total available land on our planet divided into land and ocean. So ocean is larger, of course, over 70%. But then as you keep going down into the yellow, there's division between habitable land and like not habitable land. It could be pure forest, it could be barren land, not fit for human survival. And it keeps dividing it. But it's always a percentage of the habitable land, not the inhabitable land. So the next one tells you half of our habitable land goes to agriculture. Period. Anything agriculture, anything protein. The other half is like forest, it's shrubbery, it's what have you not. Breaks it down again. Now we get to the really interesting part. Of the 50% of our habitable land used for agriculture, 77% is livestock related activities. Any livestock. Only 23% is crop, plant-based crop, period. It doesn't matter what the residual use of that crop is, it's a plant-based crop. Now we break that down again. Of the amount used for agriculture, which is 50%, now we're talking, look at the chart, caloric supply. Not necessarily protein, caloric supply. Out of all that land used for the livestock, out of that 50%, all of our calories, only 18% comes from livestock, which means that 82% or 83% is coming from the plant-based activities. Now, let's talk about protein. Everybody's always talking protein. The same land we talked about, how it's divided 77 and 23 for livestock and plant-based activities. It's a bit higher on the protein supply because meat has more protein than calories. So you get about 37% of the worldwide the protein intake from the livestock activities. But nonetheless, 63% of the protein on this planet going to a human every day or another animal is 63% from plant-based. So we can see the clear evidence here that the plant-based, using a fraction of the amount of land of the livestock, is giving the lion's share of the result to benefit our life. So that's one fact that seems quite obviously clear. So I'm going to go back to the acronym page again, sorry. We're going to talk now about animal sourced food. Animal sourced food is a lot simpler than it sounds. It's resources used to raise or graze or rear an animal for meat specifically related to food. Right? So in summary, how much food is grown and harvested to feed animals, to receive the consumption of the meat we get from it. And that's compared to the direct human crop consumption. That just means I plant wheat, I harvest wheat, I eat wheat. Other way is I plant wheat or corn, I process it, then I feed an animal, and then I kill the animal, and then I get meat. So it's more direct, less loss, less shrink. Now we're going to go to the HDP. If you remember, we said it during the land use ratio. The HDP, simply human digestible protein. It's the amount of required, like inseparable human digestible protein, like basically the amino acids that keep you alive. That's what grows your cells, your body growth, your muscles. It makes your organs function. If you don't have human digestible protein of any kind, you're not going to live very long. You're not going to grow. Severe malnourishment. It's just a matter of time. And it's not a long time either because you're not getting the nutrients required. So that's what HDP means. It's a form of protein. Now the next big one is, we're calling it FCR. Feed Conversion Ratio. I'm going to put this chart up right now so you can sort of have a look at it as I'm talking. So feed conversion ratio, in simple terms, the amount of food or feed fed to an animal from the beginning to the end process, which means slaughter to meat, compared to the amount of human digestible protein we get from it. So basically, the calculation is based on food and feed only. We're not talking water, we're not talking fuels, we're not talking any other resources. We're literally talking the food or feed we gave to the animal in comparison to what we got back from the animal and the ratio. We already spoke about the water and all that in the last video. It was quite insurmountable numbers. And it has been determined that farm to table is the most efficient use of land use because it results in a higher percentage of edible human digestible protein from plant-based, because there is always energy used, more processes involved, there's loss in the extra steps of processing to feed it to the animal, there's loss in the percentage of what you get from the animal, so that's just quite clear. And if we look at the chart I've put up there of the feed conversion ratio, we can see that on average, beef, from every source I could find, ranges between about 9 and 11 kilos of feed they receive, and their return is a kilo. It goes a bit down with sheep. I found it between 7 and 9, so I took the middle road of 8. Pork, less. It was usually between 3.5 and 4.5, so I went with 4. So we give a pig, over the 7 or so months that it takes to raise it, about 4 kilos of feed to get back 1. Believe it or not, chicken was the best. It's about 2 to 1. So for every 2 kilos of feed, we get a kilo back. And it depends, you're talking broiler hen, blue hen, red hen. It was anywhere from 1.7 to about 3.2. So I took the middle road of 2. So you can see, plant-based is 1 to 1. I take 1 ratio of any resource, I get 1 back. Just based on the food conversion ratio, the feed conversion ratio, without the other resources, the best one is chicken at 2 to 1. And once we implement water and everything else, it's significantly higher return than 2 to 1. Now, the next thing I'm going to do is I'm going to go back to the acronym chart again, just so we can refer back to it. We're going to talk about life cycle assessment. That's the last one. This is a concept that analyzes the use of natural resources. All natural resources. It's a holistic thought. Fossil fuels, land, feed, energy, everything, in the entire life cycle of a product. And this analysis would quantify or prove, I guess, the land needed to produce a kilo of animal-sourced protein. Specifically, combines information about the crop productivity, like a yield per acre or a yield per hectare, the animal productivity, the feed and efficiency, the breeding, the rearing, and the producing of the animals. And they have determined, as a scientific community, that there's different life cycle assessments for everything. Like a cow, a chicken, a pig, corn, potatoes, all of it. But what they seem to agree upon, beef is the worst life cycle assessment. Then it goes down to pig, chicken, then you have like dairy, egg and milk, and they're a little bit better than all the other ones put together. I'm going to show you one more time, because I think it's important we keep going back to this picture here. I'm going to show you the water. Remember the water, that was impressive. I found a very graphic portrayal of how we use it. So you're seeing a bunch of water bottles here. Under each one, like the first one you see is wheat to produce bread or what have you not. It's the lowest water consumption table to produce the kilo. And it's not low, it's 1600 liters still. Then you go to rice, which is approximately double. It's about 2500 or more liters to get a kilo of finished rice. Look how it jumps to pork. Over 5,000. Actually almost 6,000. Then you go to sheep and it's like almost 9,000 almost. Then it jumps to cattle, like steer, cow, 15,500 almost. That's where our water goes, and this has been agreed upon. We're talking water footprint, not that the animal drank 15,000 liters, but the entire process, what it took to grow the crops, everything. We're talking the water footprint of that animal, which has been a generally agreed upon number from all references. Now I'm showing you a picture of a nice farm. Let's pretend that farm was 500 square meters. Believe it or not, in that 500 square meters, that's about what it takes to get 1 kilo of protein. Talking about land use ratio again. Like we said, 1 to 1 is kind of the minimum land use you want, because it means you're getting about what you put in. If your use goes higher, then it's worse. If your use goes lower, it's better. So an example, we said dairy and milk was the best, eggs. They have a land use of 2.1, chicken is 2.09. That means that whatever land it took to get your milk, your eggs, the return on the protein, you would have got double the amount if it was plant-based. Or, having said it differently, it takes half the amount of land to get protein from a plant-based than milk or chicken. And it goes up and up and up and up, all the way up to like 20 to 1 for beef. It's also quite high for many others. So what I want to do now, I want to show you another amazing chart here, and this one is the world chart. So it's not directly related to meat. We are talking a lot about vegan vegetarianism here and how our lifestyle has to change. Otherwise, we are going to have such a hard time. We did talk about last time how the Western diet is sort of changing a little bit. The meat consumption per capita is going down, although population is growing. So that means the total number, of course, is higher. But look at this chart I'm putting on there right now. This is a global food use chart. And it's a very interesting chart produced by FAO. And what they did is they took into account every country's consumption habits of everything they eat. And you have three color tables. So if you look at the kind of the bluish one, the bluish one means that if the entire world followed the diet and the protein caloric consumption of those countries, from what we're doing today, we would have more than enough food to feed everybody. There would be surplus. Now, it doesn't mean they're all eating healthily. Maybe there's undernourishment. We don't really know. It's just a broad-based look at everything. Now you look at the yellow countries. If we follow the diet patterns of those countries, we would require more resources, more land, and more throughput to survive on that kind of a base diet compared to what we're doing right now as an average worldwide. Now look at the orange one. That's a scary one. If we followed the diet habit of the countries in orange, you'd almost need 2 planets. There is no way, based on the habits of the countries in the orange color, that we could survive even with the amount of people we have today. Forget the population growth and how fast it's growing by billion compared to what it used to be. We wouldn't survive today. There would be mass starvation if everybody ate that way. So that's just a habit I'm trying to show you that we need to change. Not only should we try to be more vegetarian to get more caloric based intake, more protein based, not including the greenhouse gases, not including everything else we're doing, not including the land use and the deforestation of the rainforest and the clearings, we could survive so much healthier and have such a more population survive on the
Heroes
planet
never die.
if we followed a plant-based protein, or at least a reduction just based on this chart. And that chart is a few years old. I mean, it's not current of 2020. It's probably like 2012 or 13, but it's actually intensifying. We're consuming more and more and more, so it's getting worse. It's actually not improving as a planet, as a species consuming the planet. So I'm sorry the video went a bit long. Thank you for listening. It's really important that we share this today, because in the next video we're going to talk about the deforestation and where we're going to live, how much food we need to live compared to how much we're giving the animals compared to what we're getting out of it. What is the only logical solution if we keep going down the path we're going now? It's shock and awe. We have so many attachments to the wrong things. We're not doing things right by the planet. We're not doing things right by our own health. That's obvious. You just look historically where we're headed. We're improving in some things, but as far as health goes, not so much. So leave me your comments down below what you thought of it. It was a lot to take in. You can download it off the video. Ring the bell if you want to hear more advisements. Subscribe if you want to know more about it. And please, take care. Thanks for watching. And stay tuned for part 3 as we go deeper and deeper into the can we survive, or we are on our way to our extinction as a human species based on our food habits alone and what it takes to have those habits. Take care. Have a great day.